we've got math in the PM, workplace 30, scatter plots and linear trends. So everybody's with me? Good. So what's this all about? I'm going to read with you guys this stuff here. In the previous section, you've seen that it's often useful to draw graphs that help you analyze and understand data. A scatter plot is a particular type of graph used to discover a relationship, if any, exists between two variables. Points that represent data are drawn on a coordinate plane, so graph paper kind of stuff. Then the graph is examined to see if a trend or a correlation exists. So a correlation is a trend or a connection between the two things you're looking at. You can examine if the points all seem to cluster around a straight line or if they're widely spread all over the graph. If they cluster and they look like a straight line when you plot them, it's probably well correlated. More about that in a second. If there appears to be a correlation between the points, you can draw a line of best fit. We'll take a ruler and we'll try that out in a minute. This is a line that shows the general trend in the data. It does not pass through all the data points, but instead is drawn so that approximately the same number of points appear above and below it. If the points cluster close to the line of best fit, there's a strong correlation. If they spread further out, it's weak. Using a line of best fit, you can find the following information about it. The shape, is it a linear, a line, or is it curved? Is it weak or strong? A connection there. The direction, is it positive or negative? If it's going down from left to right, it's negative. And do outliers exist? Outliers are points that are way outside of the line. We'll see this now all by doing it. So for example here, for each of the scatter plots below, well, there's some on the other page, describe the relation. Now let's just take a look here. With this ruler, and you try not to, you don't ever go dot to dot. Don't do this. Go like here, 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 here. That would be the wrong thing to do. It's very misleading, okay? So you think though, does this look like a straight line though? Kind of, like, it's not that, not the blue. But just think of this. Do these appear to be going kind of like this? Like when I put that line in there, that's sort of what these are doing, right? So this is what I would call a line of best fit. It does look like they're increasing as, you know, X and Y as you go over that. It seems to be spreading out sort of in a line. It's definitely not, like if there was no connection, your graph would look like this more, like it'd be like dot here, dot here. You see what I mean? That would have no, all those dots would have no connection. But these generally, you know, it's a pretty good connection there, actually. So you ask, or you're asked, hi Joe, working on some stuff from before, and you know, I forget, you have stuff, right? You have this one? I forget. But work on what you have first. Okay, sorry guys, I'll keep going here. This is definitely linear, because it looks like a line. There's no curve to it. But is it direct or partial? Remember, direct ones go through 0, 0. Partial starts, if it was up here and went like this, that'd be a partial variation, right? You know, if you had the, I didn't mean to do that. So, partials have a non-zero intercept. Back to this. So it's direct. That's what that means. And it's direct. What's the direction of the correlation? Is this a positive or a negative slope? Tiana? From left to right? It's positive. Thank you. There's a positive correlation. That means as one increases, the other increases as well. It gets bigger. Now, what's the strength of this one? I would say it's not the strongest, but it's not that bad. But well, it's not like really close. So let's say it's weak, but it's at like a medium kind of. But it's not a perfect fit. Yes, like you guys weren't totally convinced that that would be a straight line. It is, but it's weak. Are there any outliers? Is there anything way, way off? Well, here's what I would mean. If there was a dot over here, I'd call that an outlier. There's nothing that bad. Like these are out there. This one here is, they're out. You could argue that maybe those are outliers. But how about this? Not too bad. I wouldn't say absolutely no outliers, but you know, maybe this one, maybe. It's on the edge of it. The other ones are pretty close to touching the line. Now, I'm going to flip the page and we'll just see if you guys can figure these out. Does this look like a straight line if you kind of follow the general trend? Well, there's two of them right off the bat. Any outliers? I'll put a circle around them. I'm going to tell you ahead of time. These look way off of the pack of data. But is there a trend there? From left to right, the rest of the data, doesn't it look like it goes down? You guys take a second and just draw in a straight line what you think. It's definitely not going to hit most of the dots. Sort of so that it goes down-ish. You know, in this general area, draw one line that kind of goes in that direction. Does that make sense? Okay. Give me a second there. And okay. So hopefully you have something that looks like kind of like this. Yours doesn't have to be exactly the same as mine. It's in that ballpark. Does that look linear? I'd say that's not bad for a linear. Yeah, I'd say that's linear. By the way, I think this is an outlier though too. Yeah, maybe. It's hard to say. That one's arguable. So I'm going to say this is linear. Is that direct or partial though? Does it go through 0, 0? No. So that's definitely partial. Because it doesn't go through 0.0. What's the direction of this correlation? Tia, do you know what we're asking there? Is the slope positive or negative is really what we're saying. Yeah, definitely a negative correlation. As one thing goes bigger, right, or you go 1, 2, 3, 4, the other thing goes down. That's why it's negatively. Is really what you're saying. What's the strength of this correlation? I'd say quite weak, right? Very, very weak. But there is one. Are there any outliers? I circled them. Let's say that there's 3. Okay. Now, the third one here. What do you think about this one? Is there a correlation? Is it linear or not? What do you guys think? No connection. There's nothing. No connection or correlation. Don't have to do anything. That's garbage up. How about this one? Does this look like it'd be a line? I would say freehand, just sort of follow this path. Doesn't it look like that? It's a curve. So it's not a line, it's non-linear. You can still answer the other questions though. Let's see here. What's the direction of the correlation? Is it going higher or lower from left to right? So it's a positive. It's still positive. And And actually, that's a very strong correlation there too, eh? Like they're quite, it's a strong one. There is, I'd say, because it's so strong, there's one outlier. Circle. Because all the other ones touch that curve that I drew anyways. You're stumped? Okay, I'm recording this right now, 2 over, so I'm not going to stop too much. I'll have to hang in there until I set these guys free. Any questions about that? No. Okay. So the line of best fit. I've been showing you already for lines of best fit. Now this is a tricky one. Draw a line of best fit and then write an equation. We're going to use it, I'd say if possible, make your mx plus b. If you can make, if it looks like it's 0, use 0 as a point, because then it makes your equation easier to do. Does this kind of look like what the data does, or would I want to move it down a bit? Like you kind of guess. Yours will be different than mine, and that's fine. You know, is there about half of the data, 1, 2, 3, above? So there's 1, 2, 3, 4, 5 parts there. 1, 2, 3, 4, 5. Yeah, it's about the middle of the data, I'd say. You maybe could pull it a little lower. That's up to you, though. Then, how do we come up with the equation of your line? Okay, does everyone have a line of best fit? If you went through 0, 0, it makes your next step easy. Because if you want an equation for your line, you need the slope. And if you start at 0, 0, that means just, what's an easy point to rise up to and read? Do you see that this point is kind of like at 5? Doesn't it look like that? Or actually, no, this one looks, on my line, almost looks exactly. This one's, I see a little over 5. 8, 9. Oh, I said 5. Should have been talking 7. But this point here, I think that looks like it's exactly on 9 right there, right? 9 and 5 there. So I'm going to use this point to do my slope, because that is 9, 5. Of course, this other point is 0, 0. Now that's my graph. If you look on yours, if it looks like that on yours, you use what you have. But to find the slope, you can use y2 minus y1 over x2 minus x1. So that's really just 5 minus 0, which is 5. 9 minus 0. There you go. You don't have to get a decimal for that. I don't know what yours is, but it'll probably be around there. Yeah? So there's my slope. My handwriting doesn't quite look great. Now the general equation of a line is y equals mx plus b. This is the x-axis here, and the y-axis goes up and down. And what is the b value here? I mentioned, try to pick it as 0 if it looks like it should be. Because then it makes your equation way easier. Y equals 5/9 is your m, x. And that's the equation. Not a lot of, in this case, there wasn't a lot of work. Hey, the two of you, books open, working away. You done everything? What's that? You didn't bring any. You done everything. Okay. Now, back. Justine, are you done everything too for Miss Rogers? Okay, where am I? Your assignment, I think you guys try these out. Anyways. I'm going to stop the recording and help some people with some other items.